Hello, writers. The purpose of this video is to give students who are absent an opportunity to get the missing class notes. Also, it's very likely that we did not get quite to the end, so you'll need to watch the end of this video to fill in your missing notes. And lastly, an opportunity to try to do the math problem at the end of the notes without looking at the solution. Please remember, all class notes should be in Cornell note style. Questions on the left, answers on the right. They should be numbered. If you find mistakes in my numbering, just stick with what I have, as I am looking for a final number at the end. Of course, because this is a video, I will be going a little bit faster than I do in class. You can always pause the video. I will warn you when I'm getting ready to move on to the next slide. Also, please use this as an opportunity to pause the video, look up answers for the whiteboard questions. I will give you hints as to where to look. Every minute you spend studying your notes now is a minute you don't have to spend studying for the test or the AP test later. All right, here we go. All right, Chapter 20 deals with climate change. A lot of Chapter 20 is a review, of course, because we've been talking about this all year. Weather, short-term changes in the atmosphere. Climate is the average weather over a long period of time. All right, greenhouse effect is the ability for certain gases to retain heat within the atmosphere. The big three are carbon dioxide, methane, and nitrous oxides. Historically, changes in CO2 and temperatures are pretty much identical. If you looked at graphs over the last couple hundred years, the increase in carbon dioxide seems to mimic the increase in temperature. Therefore, you might suggest that they are related. Sorry, moving ahead in 3, 2, and 1. All right, so natural factors, volcanoes, changes in the amount of solar radiation that comes in, slight changes in our orbit, distance to the sun obviously is related to changes in orbit, changes in ocean and air circulation patterns, and changes in the amount of reflective ice, albedo. As you know, the poles, both north and south, are melting at rapid rates. And when the ice no longer can reflect the sunlight, it gets absorbed by land or water, which keeps the heat on the planet, whereas where it gets reflected, it goes right back out through the atmosphere to space. So that's kind of a double whammy, and that is referred to as a positive feedback loop. Moving ahead in 3, 2, and 1. Climate change happening now. Temperatures have increased nearly an entire degree centigrade in the past century. 10 of the hottest years on record have happened since 1905. That is disturbing. The hottest year on record is 2016. North and South Pole shrinking, been talking about that. Glaciers are also shrinking. Permafrost is land that stays frozen year-round. That is starting to melt, and it's releasing a lot of methane. Carbon dioxide and methane in the atmosphere are increasing. Ecosystems are changing. Organisms on land are migrating to what used to be colder areas and are now warmer areas. They're doing this on a local scale also by moving up in altitude on mountains, and this is crowding out native species. It's creating opportunities for invasive species, and of course, if these native species are threatened or endangered, it could be detrimental and even cause extinction of these species. Moving ahead in 3, 2, and 1. All right, 3 biggest greenhouse gases. What relationships suggest humans are responsible for climate change? Take a look at number 2. All right, answers coming in 3, 2, and 1. Carbon dioxide, methane, and nitrous oxides, and temperature and carbon dioxide concentrations and temperature changes are similar. What 2 natural factors are 2 natural factors that affect climate change? Take a look at number 3. Yeah, so we got volcanoes, changes in solar activity, changes in orbit, ocean and air circulation patterns, changes in reflectivity or albedo. 2 things that demonstrate climate is changing. Climate change is happening now. Take a look at number 4. Yeah, the temperature increase over the last century. 10 hottest years are all recent. Shrinking poles, permafrost, methane, carbon dioxide in the atmosphere, changing ecosystems, invasive species are increasing. Moving ahead in 3, 2, and 1. Human activities, primarily fossil fuels, are related to climate change. Burning fossil fuels, cutting down forests. AG is agriculture, GHG is greenhouse gas. Planting farms rather than forests, or clearing forest land for livestock, which adds, of course, methane and reduces the ability for plants and trees to pull CO2 out of the atmosphere. Carbon cycle naturally takes CO2 out of the atmosphere, but we're putting so much in so fast it can't keep up. Fossil fuel lifestyles leading to air pollution, climate change, and ocean acidification. Remember, carbon dioxide mixes with water to form carbonic acid, which lowers the pH of oceans, and that limits the ability for shell creatures and corals to build their shells and build their skeletons. Raising livestock and deforestation are tied. Lots of land gets cleared for raising cattle grazing. Lots of land gets cleared to grow food, to feed the cattle. Forests are a carbon sink, so if we remove forests, we are removing the ability for them to take CO2 out of the atmosphere, and also we are removing that carbon that is being stored in plant tissues, many times burning it, which goes right back into the atmosphere. So it's a double whammy. Moving ahead in 3, 2, and 1. Methane issues. It's more potent than carbon dioxide by about 25 times. Livestock, when they are eating and swallowing air and the food, they are burping up methane. Methane comes out of their rear end as well. Rice produces a lot of methane. Natural gas production for energy. Melting permafrost, a lot of that methane is being stored in frozen grounds, and as it is melting, that ground is melting, it's releasing it to the atmosphere. Human-caused climate change, or is it natural? Climate deniers will say that this happens many, many, many times in the past. The big difference is scientists are shocked and worried about how rapidly it's taking place. So it's much faster than natural factors could do, leading to the fact that humans are involved. Climate scientists use models. They think climate change is happening now. We need to act on it. They think that human activities play a big role. They think our atmospheric temperatures will continue to increase, and they think that immediate action is possible currently with the technology we have, and that it's affordable. Moving ahead in 5, 4, 3, 2, and 1. Involvement of the sun. Scientists say that warming cannot be caused by increased solar output. The output of the sun's actually been less over the last few decades, so that argument is completely blown. The troposphere, the layer of the atmosphere that we live in, is actually warmer, and the stratosphere is cooler, which suggests that the heating is moving from the bottom up, whereas if you had an increase in solar output, it would be heating the layers of the atmosphere from the top to the bottom where we live. So it's opposite of what you would expect if the sun were involved. Moving ahead in 5, 4, 3, 2, and 1. What are 2 human activities that contribute to climate change? Pick some other than fossil fuels. Take a look back at number 5. Yeah, cutting down forests. Let's see. United States citizens, in particular, have a larger carbon footprint than others. Deforestation's a big one. Livestock. There are lots more, of course. How does raising livestock contribute to climate change? Twice. Take a look back at number 4. Beg your pardon. Take a look back at number 5. I'm sorry. Yeah, so not only does livestock produce methane by burping it and by having it come out their rears, but in addition, um, cutting down the forest removes the ability for forests to take carbon dioxide out of the atmosphere. In many cases, we are actually burning the forest, which of course takes all that stored carbon and releases it to the atmosphere. So it's a double whammy. What are two things you learned about methane's contribution to climate change? Take a look at number 7. Yeah, it's worse than carbon dioxide. It comes from livestock, rice, melting permafrost, um, mining natural gas for energy production. All right, moving ahead in 3, 2, and 1. All right, oceans and climate change. Remember, oceans are also a carbon sink. It's stored in marine algae, vegetation, coral, animals, bottom sediments. They absorb heat from the atmosphere, so they help regulate the temperature. Although, when oceans are warming up, that is decreasing their ability to store dissolved oxygen, and that's harming organisms. More dissolved carbon dioxide leads to carbonic acid and bleaching of corals, also harms shell creatures. Moving ahead in 3, 2, never mind, there's another one. Sorry. Cloud cover. Scientists don't think that the net effect of cloud cover change is likely to increase the warming. Clouds do absorb solar radiation. Water vapor is a greenhouse gas, but they don't think that increased cloud cover is likely to influence climate change a lot. Moving ahead in 3, 2, 1. There are numerous types of clouds, but the two that I'd like you to know about are cumulus clouds. They're a lot thicker, a lot more dense, and they reflect light back out into space. Cirrus clouds, these wispy high altitude clouds, actually allow temperature through, and they kind of insulate the planet to an extent. All right, outdoor air pollution and climate change. Aerosols like sea salt, which have sulfates in them, actually reflect sunlight, which is a good thing. Dark particles, on the other hand, absorb heat, keeping the heat in the atmosphere and on the ground. Scientists don't think that outdoor air pollution, other than greenhouse gases, is going to have a huge impact on climate change. Moving ahead in 3, 2, and 1. Reducing or slowing climate change. A big one is just greenhouse gas emissions. We have the technology, we can actually save money and increase human health, um, which will decrease the amount of taxes we have to pay. Because when insurance companies are struggling to pay claims, they get bailouts from the government, and the government gets their general fund from taxes. Less wasting energy, more clean energy. It's going to be difficult. The biggest one, in my opinion, is global international cooperation over a long period of time. It's tough to ask developing nations to ignore their coal reserves. Coal is cheap energy. It's a way to get electricity to their populations to reduce poverty. It's political in some countries, especially in the United States. Unfortunately, the poor and non developed nations are going to suffer more. So, climate change, harmful and beneficial impacts are not spread out evenly. Economic disruption could come from changing policies currently, and certainly will come from battling the effects of climate change in the future. We need more research to reduce the uncertainty. It's difficult to fund projects when we're uncertain as to whether or not they're enough or will even affect a changing climate. Moving ahead in 5, 4, 3, 2, 1. What are two ways oceans are involved with climate change? Take a look back at number 10. Yeah, they're a carbon sink. They absorb heat from the atmosphere. Let's see, more dissolved carbon dioxide getting into the oceans increases ocean acidification, decreases pH with carbonic acid. 2 ways to reduce or slow climate change. Take a look at number 13. Yeah, greenhouse gas, we need to reduce it or eliminate it. We need to get more renewable technologies out there. We need to get our energy in a cleaner fashion. Human health will benefit from that. Which 2 obstacles do you think will be the most difficult as a planet? Like I said, personally, I think it's going to be global cooperation over a sustained period of time. In my opinion, for the US, it's going to be difficult to get past the politics of climate change. Personally, when we're talking about the future deaths of hundreds of thousands or potentially millions of people related to climate change events, I think it becomes a moral or an ethical issue, which should not be politicized. Of course, the Republican Party is very interested in maintaining our economy, getting our energy as cheaply as possible. They are not as concerned about the environment, typically, as are Democrats. But if we can make it a moral or ethical issue, and it's about saving lives and it's about making our planet better for future generations, I think we can get away from the politicizing that we have in the United States. Whether that'll happen, I'm not sure. Moving ahead. Let's see. Options: mitigate, compromise to slow down climate change, to avoid the worst effects. I don't really like adaptation. Adaptation basically means we recognize climate change is going to happen, and just basically preparing to adapt to some of its harmful effects. We need to make sure we avoid climate change tipping points. Big tipping points. Greenland's got between 21 and 23, as I read more recently. Ocean level rise, very unlikely that it'll all melt this century or maybe even next century. But even close to 5, 6, 7 feet of sea level rise is going to devastate many coastal cities around the world. Not to mention the nation islands that will be completely gone. Carbon sink release, cutting down forests, releasing carbon. Oceans are unable to take in as much carbon dioxide and permafrost melting. And then ocean and air currents could be altered. I'm really concerned about this ocean current, which keeps the eastern portion of the United States, the northeastern portion, specifically warmer, and Europe. If this ocean current stops, the warm Gulf water stops going up here, Europe could go into an ice age. Not the northernmost, but the mid-Atlantic states could start freezing and having snowfall earlier. Also, when you stop the circulation of ocean water, you could have a lot of nasty stuff growing in there. It could create a lot of toxic gases, which means people would have to move away from the coastlines. And the majority of the people in the world live near the coast. Moving ahead in 3, 2, 1. All right, economies. Most developed nations have fossil fuel-based economies. Shifting is going to be hard. It has been done. Germany and other, Norway, the Netherlands have all made great strides. Realistic starting points: we need to decrease black carbon and methane use, fossil fuels, drive less, we need to carpool, buy hybrids, electric. As people stop buying more gas-powered vehicles, that will increase the price of them. As people buy more and more hybrids and electric cars, that will decrease the price of them. You need to think about it. Live more thoughtfully. Make climate change, saving energy, reducing your waste, eliminating your waste, part of your lives. Think about it. Waste less. Talk about it. Try to influence people that maybe don't think that the way that you do, or just simply don't think about it as much as you do. Those are potentially awkward conversations, but it's about making the planet a better place for the future. Moving ahead in 3, 2, and 1. Oh, never mind. All right, so cleanup options. Pick 2 of these. Sequester means to remove. You don't need to write that down. But sequester means remove or reduce. So pick two of these methods of cleaning up the CO2 that we have in our atmosphere. I'm moving ahead in 5, 4, 3, 2, 1. Capturing CO2. Plant trees wherever they're not growing. Plant them in poor soils. Biochar is a concentrated solid form of carbon that doesn't dissolve or get back into the atmosphere. A perennial is a tree that has its leaves year-round. Plant those on degraded lands. The lands that have been used for farming where the soil is no longer fertile, plant them in brown fields. Plant them especially in cities where there's more pollution. There are technologies to capture and store the carbon from coal-burning plants, but that increases the cost of that. We do a lot of that in the United States already. That needs to happen on a global scale. Moving ahead in 5, 4, 3, 2, and 1. Which tipping point are you most concerned about? Greenland, or air and ocean currents, or carbon sink release? Personally, I'm most concerned about Greenland and sea level rise. What is one starting point you can commit to do? You personally can commit to do. Take a look at number 18. I can ride my bike more. I can carpool more. I can talk about it. Shoot, I do every day to you guys. I do it to my friends too. You gotta pick your moments. What are your two favorite choices for carbon capture? Take a look at number 20, 19, or 20. Personally, I like tree planting. I like the idea of storing carbon in biochar and putting it back in the soil, making it solid, make it available for plants. Moving ahead in 3, 2, and 1. Geoengineering. This is one of the science focus items. It's basically manipulating nature to counter the greenhouse effect. Remember, the greenhouse effect is good. We need those gases to keep heat in our atmosphere, which keeps the surface warm. Unfortunately, the greenhouse effect is getting better and better because there are more of these heat trapping gases being put into the atmosphere. Examples: inject sulfate particles into the stratosphere. Remember, sulfate reflects sunlight. I'm not sure I like having a lot of sulfate in the atmosphere. I'd have to do a little bit of research to find out if it's harmful when it gets back to the surface, or it can get back to the surface. If it can get back to the surface, spray salt water into the sky. Remember, light particles reflect sunlight. Pump nutrient-rich water from deep oceans to feed algae blooms. Obviously, we're going to want to make sure these algae are not toxic, and you're not doing them in areas where a lot of people are going to be swimming. But more photosynthesis means more CO2 coming out of the atmosphere. I have problems with this. Unknown side effects: sulfate, having salt in the air. Massive cost on energy and materials. It might actually increase fossil fuel use. We'd have to look into that. And there are political and ethical aspects about this, and that's probably related to some of the unknown side effects. Moving ahead in 3, 2, and 1. Government and greenhouse gas emissions. The government can regulate methane and carbon dioxide as air pollutants. They can actually put caps on the amount that companies and cities and urban areas are adding to the atmosphere. Got to phase out coal immediately. Got to do it. Tax CO2 and CH4 emissions. That's going to take legislature, which means that's going to take you voting for people who are willing to go against the legacy of political power influenced by fossil fuels. Use a cap and trade system. China's doing it. Phase out subsidies and tax breaks for fossil fuels. Again, that's going to be legislation It's going to be employing and electing people who will not do that anymore. And we have to stop cutting down trees. Definitely. All right, pick two of these. Pick two advantages and disadvantages of a carbon and or energy tax. It's simple to administer. You put a price on carbon, and that way companies can plan. Covers all emitters. Because you know the price, you can actually predict your revenues and figure out what you need to do about it as a company. Disadvantages, tax laws are complex. Loopholes especially can occur if you have fossil fuel interests still lobbying the government. It doesn't guarantee lower emissions. It simply means that people are going to be paying more to emit the amount that they do. And politically, it's unpopular, especially in our country. Moving ahead in 3, 2, 1. Cap and trade. Pick two advantages and disadvantages. It's easy to identify the legal limits. It rewards people who cut their emissions, which in many cases will be people investing in new technologies and changing the way that they do business. There is a record of success. It's worked in places on the planet. Low expense for consumers. Disadvantages, revenues are not predictable. It's vulnerable to cheating. You have to have regulators that go out and check these things, and those people might be influenced. Rich polluters can keep polluting if they're willing to pay for it because they have the money. They don't actually have to reduce. And it puts a variable price on carbon. We really, really need an exact price on carbon. Moving ahead in 3, 2, and 1. What is one example and one problem with geoengineering? Go back and take a look at number 22, 3. Yeah, so putting sulfates in the atmosphere, putting salts in the atmosphere, salt spray, taking nutrient-rich ocean water from the bottom and putting it near the surface where algae can use it so we have more photosynthesis. Problems, we're not really sure if that's a good idea. Could get political as well. What are two examples of how governments can be involved with reducing greenhouse gas emissions? And let me change this real quick, sorry. Get rid of subsidies, put caps on the amount, tax gross polluters, come up with a cap and trade program, advantage and disadvantage of either a carbon tax or a cap and trade. Take a look back at number 25 and 26. And of course, there are so many opportunities for you to do this. I'm not going to read them all off. Moving ahead in 3, 2, and 1. All right, international climate change examples. 97, Kyoto. Unfortunately, we did not agree to that. And that was because of the administration that was currently in the White House at that time. If my memory serves me, the only two countries that didn't agree at Kyoto were the United States and Kazakhstan. Personally, I could give a darn about Kazakhstan. They probably have 2,000 cars in their entire country. United States, on the other hand, that was a big, bad egg on our face situation. 2014, U.S. and China agreed to cap carbon emissions within 15 to 20 years. 2015, Paris, you guys saw all of the things that went into getting India specifically to agree at Paris. Unfortunately, the next administration that came in after Obama reversed that. But since the new president has been elected, he has gone back and agreed to what was agreed to in Paris. And this is part of what's difficult, especially in the United States, is legislation and progress that has been made by previous administrations can get overturned, reversed, and potentially even worsen than it was before, just when you have a new administration come in. And that's every 4 years potentially. It's not cool. One big problem with Paris is there's no money to help poorer countries reach the goals. The United States and Solar City and Tesla did get a deal done for India, but that was what's the word I'm looking for? Isolated example. We need to make funds and lending and technology available to all developing nations. Common theme: no legal binding agreement. So, like, there's no penalty, political penalty, or monetary penalty if you don't actually do it. They did agree, though, and they agreed that the benefits of slowing climate change outweigh long-term economic and environmental risks if not. So everybody agrees that if something isn't done soon, things could get much, much worse. And hopefully that'll sway countries to do what they said they would do. Moving ahead in 3, 2, 1. Success stories: Costa Rica. Their goal is to be carbon neutral by 2030. That is outstanding. China and India are trying to change their energy habits. China has made great strides with solar. Of course, India, you learned half of their new energy that they are planning to develop over the next couple of decades will now come from solar versus all of it coming from coal. And there are U.S. cities and states reducing carbon emissions. California is on the forefront of that. It's very difficult to drive older vehicles in California or to have gross polluting industries in California. It makes it more expensive to live in California, but it is our air is cleaner, and we do have the largest population in the United States, so it's important to have those regulations, in my opinion. Opportunities for individuals to help. 2/3 of United States CO2 emissions comes from materials like making things and construction. We need to make things with less packaging. We need to make things with more recyclable packaging. We need to make things that don't have packaging. We need to change our diets. I implore you to please, if you eat beef 3, 4, 5 times a week, try to cut that in half, or try to just, have meatless Mondays. There are lots of alternatives to beef, and they're not all great, but they're better. Also, look into how much land gets used to graze cattle and also to grow feed for cattle. We could replant that land with forests and perennial trees that are going to reduce carbon dioxide emissions and increase biodiversity. Got to get politics involved. We have to elect lawmakers that are going to reverse our course on fossil fuels and start moving those subsidies and tax breaks into research and into newer technologies and implementation of the technologies we already have. I'm moving ahead in 5, 4, 3, 2, 1. Ways to reduce CO2. Pick 4 of these. I'm moving ahead in 5, 4, 3, 2, and 1. I have 3 things you will commit to do within 10 years. Taking a look back at number 31. Shoot your first home. Replace all the bulbs with LED if they aren't there already. Commit to one of the first investments you put into your new home. Energy Star appliances or energy efficient windows. Commit to voting for lawmakers that are willing to fight fossil fuel interests versus doing some of the same or not doing anything. Those are 3 easy things you can do. Okay, Let's see, carbon footprint math. All right, so you're going to be using the information in this graph to do some mathematics. This is also found on page 639 if you're having a hard time reading it. Again, to get full credit for your class notes, you need to write down everything. The math problems mean nothing if you don't know what the question being asked is. Calculate the percentage of the U.S. contribution to global CO2 as of 2013. And of course, you're going to need to know the total for the world and then the total for the U.S. to do that. And you're going to be using the red bar. So 32.94 and then 5.12. All right, I'm encouraging you to solve this on your own. I'm going to show you the solution in 5, 4, 3, pause the video if you're still working, 2, and 1. All right, so you divide 5.12 by the total, you multiply it by 100. The US has approximately 15.6%. Here's the next prompt. In 2013, how many times more carbon dioxide was generated per person in the US compared to an individual in Germany? So you're going to go use those yellow bars for the US and Germany. All right, solutions coming in 5, 4, 3, 2, and 1. All right, so US is 16.2, Germany is 9.3. And to figure that out, you divide the big number by the small number, and that means the United States is approximately 1.7 times more by each American versus each German citizen. All right, ladies and gentlemen, that is it for these notes. Please get them turned into Google Classroom on time, and we will see you in class.